Welcome student to my channel Educare Maths and Science. Today now to introduce the physics. The first video of the physics that is actually in case of 8 and 9 also this actually the first thing physics motion in one dimension. I just write all down here and the discussion in later. Okay. So motion in one dimension. In case of physics motion is very important thing. Rest and motion is there. So in case of motion, in case of other things, first thing is measurable. Which can you measure? In case of motion, the velocity and other thing, all this type. Main thing is the measure. Which can you measure? In case of physics, you cannot measure the height. You cannot measure the goodwill of this. You cannot measure. That is an assumption. What is the goodwill of very goodwill? Goodwill of the things. The business is a very good goodwill. Or the in case of you hate something. You hate something. You hate goodwill is cannot measure. So which one first you measure? Measure means which one the physical quantity. That is called the measurable. This is called the quantity. You cannot measure the heat. You cannot measure the goodwill. It's not the quantity. It's not the quantity. Which one you first determine which one is the quantity. Quantity that can be measurable. That can be measurable. Mass is measurable. Length is measurable. So that we call the physical quantity. So in case of physics, quantity which can be measurable, that is the physical quantity. So in case of physics, physical quantity, here is the motion in one dimension, and under this the first thing is the quantity and the physical quantity that can be measurable. So these physical quantities are two types actually. Actually the two types, the basic concept of the motion in one dimension. The first introduce one new things to you. In case of 8, in case of 9 also you know that is one is scalar quantity, one is the vector quantity. This is a very important thing. First two concept must be clear in case of physics. In any stream, the main thing is the concept. Which one you determine the scalar quantity, which one you can buy the vector quantity. So quantity, physical quantity that can be measured, that can be measurable. Yet, goodwill or other things you cannot measure. You like it, but you cannot measure by any instrument. But the mass you can measure, length can be measured by any instrument. So one is very important, the different of the two measurement quantity. One is the scalar quantity, one is the vector quantity. Only one thing is there. In case of the scalar quantity, only the numerical value. Only just I write down, you just write all these things here. One is physical quantity, motion in one dimension, terms related to the motion. The first two terms, one is scalar quantity, one is vector quantity. It's very important introduction. So scalar quantity, only one thing, numerical value. Numerical value. No, this one, the scalar quantity. This is a scalar quantity. The scalar quantity, the physical quantity, two types, the scalar quantity and the vector quantity. And here, in case of the scalar quantity, only magnitude. You just determine the magnitude. There is no direction and other thing, only the magnitude. Suppose mass 5 kg rice. There is no need for magnitude. 5 kg rice or 5 kg dal or other things. That means mass. That means the physical quantity, only the mass you calculate. That means the magnitude, 5 kg. Two parameters are needed. Two parameters. One is the numerical value, one is the unit. 5 kg mass, you just 5 kg. If the 5 gram, you just compare. 5 gram is very, very low. But big, 5 kg is big. 500 kg, 5 ton is very big. Though you need the units. Your idea for the units, one is a bigger unit, one is a smaller unit. The gram is the smaller unit, kg is the bigger unit. So now 5 kg, so 5 is the magnitude value and kg is the unit. So two parameters. One is the units, this is the kg is the units, and 5 is the numerical value. Only two things you determine in case of scalar quantity. Okay, clear? So what do you mean by the scalar quantity? Scalar quantity means you can measure, but only the magnitude. Magnitude and the side by side the units. If mass, in case of small thing, suppose 100 gram sugar, 100 gram sugar. Okay, but when you brought the rice, So 5 kg. So 5 kg is a huge amount. Okay. So depends on the unit, you just determine the amount. But 5, both are 5. 5 is the magnitude. Here is the kg. Kg is the units. In case of sugar, you 100 gram. The 100 is the magnitude. Gram is the unit. So two parameters. Very important thing in case of scalar quantity. Two parameters. One is units and one is numerical value. But the certain exception is there. If there is the pure number, such as pi is the pure number, e square. So in that case, the particular the pure number pi, there is no units. Okay, but the pure number 22/7. Okay, the numerical, that there is no unit, the pure number. So this has the no units. Okay, scalar quantity. Now I write down all the common scalar quantity, the example. So mass is a scalar quantity. You remember, mass is a scalar quantity. Length means 5 meter, only 5 meter. In which direction is not needed. Length 5 meter or 5 centimeter. So these are how much length. These are depends on the units. 5 meter is greater than 5 centimeter, but 5 is the magnitude. Unit, length or centimeter, meter or centimeter. So example is mass, length, time. Time is 5 seconds, 5 hours. Distance 5 kilometer, 5 meter. Okay. Density, if this is the 3 gram per cc, 3 meter per kg per meter cube. Okay. This volume, suppose 10 liters, suppose 10 gallon. Okay. Speed, there is no need for the direction, only the magnitude. 5 kilometer per hour. In which direction this is not needed? This is for the vector. Okay. Speed, temperature, 10 degrees centigrade, potential, gravitational potential, magnetic potential, or electric different potential. These are all under the scalar quantity. And the what? Power, energy, pressure, quantity of its specific heat. The specific heat, actually the ratio, specific heat and specific gravity, they need for any scalar quantity. Okay. Specific heat, resistance. This is the Ma means actually the mechanical advantage, frequency, angle. Okay. Okay. Here is not, you write down the specific gravity. This is out of this. Okay. And the specific, this is also okay. This is no problem. Registration, resistance, mechanical advantage. Mechanical advantage is not for mechanical advantage 5. That is not need for need. The value is there. Okay, no need, but the value is there. In case of specific, it also value is there. Specific gravity also value is there. So you need not need for units also. In case of pi, supposing the frequency, the angles. Now these are the all example of the scalar quantity. Very important thing. So one important thing is that in case of the scalar quantity, that is be measurable, or addition, subtraction, multiply, division. Yes, in case of the scalar quantity, in scale of the scalar, suppose 5 kg rice. 5 kg rice plus 10 kg rice. So 5 plus 10, 15 kg. Just adding by simple arithmetic process, simple arithmetic method. You can add by simple arithmetic process in case of the scalar quantity. When the need for the scalar quantity, addition or subtraction or multiply or division. In case of the scalar quantity, this is the basic difference between the vector quantity and the scalar quantity. The concept must be clear. Okay, in case of the scalar quantity, you can add, you can subtract, you can multiply or division by just simple arithmetical process, arithmetical method. Okay, suppose and the 2 meter length is 2 meter plus 5 meter. So this is the 2 plus 5, 7 meter. Just arithmetic process, you just add it. But in case of the vector quantity, this is certain difference. First, in case of the motion in one dimension, the quantity, the idea of the quantity, which one is the scalar quantity, which one is the vector quantity, in which way you just add, what is the main concepts and what is the examples of this, the very clear idea about this. Then I go to the rest and motion and other things. Okay, so that's a basic thing. Okay, now in case of the vector quantity, in case of the scalar quantity, you need for two items. One is mass and one is units, numerical value. One is numerical value is needed. In here, suppose in case this is a mass 5 kg. So this is the numerical value, this is the units. only two. There is no need for any direction. But in case of the vector quantity magnitude is there, direction is there. That is for the complete meaning. Here, in case of the vector quantity, magnitude, units, magnitude and direction. Very important thing. In case of the scalar quantity, only magnitude. In case of the scalar quantity, only magnitude. But in case of the vector quantity, magnitude at the same times, you are always mention the direction. This is a very important thing, is the direction. So in case of the scalar quantity, only two parameters, units and numerical value. In case of the vector quantity, three parameters, units, numerical value, this, but particularly this is the direction is very important thing. Direction. So example of this, displacement, distance and displacement. There's a very important difference. Displacement and displacement, distance. Suppose from here, suppose point A, this is a 5 meter. So this is a distance also. But what is the direction? This is a suppose a north, east, south, southwest. In case of displacement, here you read, right, the from the A 5 kilometer towards east. That is the complete meaning of displacement. Displacement, distance is this. Here, suppose from here, this is 5 kilometer, this is also 5 kilometer, this is 5 kilometer. But all of the 5 kilometer, this is the distance. This is the distance. But it's not the displacement. Displacement in which direction? 5 kilometer towards east, 5 kilometers towards north, 5 kilometer towards west. That is the complete meaning of displacement. Okay. So suppose here, I just clearly understood. Say suppose a point is here. Suppose it's a right angle triangle. Here, ABC. Here is 6 kilometer. Here is, suppose this is 5 kilometer. This is. So it's starting from here, A to B, B to C, then C to A. Okay. Or directly you draw in this way. Very important thing here is this. You start from here. This is 5 kilometer. This is actually this is 5 not. This is a 5 square. This is 4 kilometer. This is 3 kilometer. So here is starting from here A to B. This is 4 kilometer, and from B to this the 3 B to C is 3 kilometer. So this is the total distance covered from A to B, B to C. Total distance covered 4 meter and 3 meter, 7 meter. Actually the displacement, this is the distance A to B, B to C. A man just covered from A to B, B to C, 4 kilometer and 3 kilometer. That is actually the distance covered. But what is the actual displacement? Displacement means the initial position and the final position. So if you add it, that is actually the displacement. That is a very important difference of distance and displacement. So in that case, actually the displacement is, if this is north and this is east, this is west and the south, this is the actually northeast direction. This is the north, this is the east. So actually the displacement is north to east direction. And this is actually, in case of Pythagoras, this is 16, this is 9. So this is. So difference. Total distance covered by man A to C, 4 and 3. 7 meter is total distance covered. But what is the displacement? Displacement actually from final position and initial position. This is the final, this is the initial. So actually this, in case of the Pythagoras, you just write 5. So 5 kilometer is the displacement actually towards northeast. This is north, this is east, so towards this. So this is the very important difference. So displacement is this. Always the direction. In case of velocity also, 5 kilometer per hour towards north or towards east. That is actually the meaningful of the velocity. Acceleration also this, impulse also, weight, you know, all the weights, gravity is towards the center of the earth. That is the direction is always this weight, mass is acting towards the gravity, center of the earth. So this is the towards, that is the direction. So always downward weights. So this is the direction. Temperature gradient, in which inclination the temperature increase, electrical field also, magnetic field, dipole moment also. So this is all the displacement, and displacement of the force also displacement. So displacement is denoted by F. Suppose this one, if you just rub it, this is the direction. What is the meaning? What is the symbol? Actually force, actually you write in this way. So this is actually the denote of the vector quantity. If direction is this. If there is a direction, this is the negative, that means is the opposite. That means this force is acting in this way and this force is acting in this way. For that, this is the negative sign, the vector negative sign. So in case this is a force, the arrow sign is indicate the direction and the force value. If this is the meaning. What is the meaning of this? This is the positive, this is the negative. That means this force in this direction and minus this for this in opposite direction. Okay, clear? Now one basic difference. In case of the scalar quantity, you add, subtract, multiply, or division is a simple arithmetic process. But in case of vector quantity, you cannot add, subtract, or multiply, but just a simple arithmetic process. There is a different algebra. This is called the vector algebra. Okay. So add, subtraction, and multiply. These you need for a different algebra. You cannot easy way to add in a vector quantity. This is a separate algebra, the vector algebra is there. This is not the simple way. In case of the scalar quantity, you just add in the simple arithmetic process. But in case of the vector quantity, you cannot add in the simple arithmetic process. This is for the separate algebra. This is called the vector algebra. This is for the higher study. Okay. So this is the thing. Okay. Clear? So this is a very basic conception of this. And one is very important here. I write first. Numerical value of the vector quantity. Numerical value 5 kg. This is the numerical value. Or the force. Suppose a force Newton of time. Force 5 Newton in direction. Numerical value of the vector quantity is 5. Also with the gives units in the magnitude. That means what is this indicate the magnitude of the force. But if you just direction arrow, that means in which direction the force is applied. This is the direction, that means in which direction the force is applied. Numerical value of the vector quantity, also the units, give us the magnitude of the quantity. It always positive. This means 5 means always positive. Always positive. Negative sign of the vector, that means the opposite direction. If this is in this direction, suppose a force is acting in this direction, the 5n. If this is minus 5n, this, that means actually this minus means this in this direction. Okay, that is a very meaningful thing. Negative sign with the vector quantity, that means actually the opposite. This and this means this and this is the opposite in direction. Okay, so this is for today. If you understand, please share and subscribe the channel. Next day, I just going upon the this type of motion in one direction is a separate rest and motion and other things we'll discuss gradually step by step. Okay. So thank you student. Thank you for today. Okay. Thank you. Here is the one thing. Suppose one thing. These are north, south, east, west. Okay. So just an example. If I just move, this is the body. If you just move in the 5 meter, this is meaningless. This ball is moving 5 meter. This is meaningless in case of the vector quantity. 5 meters in which direction? This is the proper meaning. 5 meter in towards north or towards east or what west or towards south. That is the proper meaning. So if you just apply a force 5 Newton towards north, that is the proper meaning, or towards east. Only they apply the force 5 meter is not the proper meaning. 5 meter force is applied in which direction? This is the particular speciality of the vector quantity. Okay. So this is for today. Thank you. If you just understand this, please share the channel and subscribe the channel. Thank you. Thank you, student, for today.